Day 32, lesson 80, so the last lesson out of the first semester. What we are looking at is transformations. Transformations is just a change in a shape. So two figures are congruent if they have the same shape and size. If everything about them is identical, we call them congruent. 1 and 2 are congruent, but they're not in the same position. So what does it look like happening from here? We can use 3 types of position changes to move triangle 1 to the position of triangle 2. One position is to flip the triangle over as though flipping a piece of paper, as shown on the following page. So if we flip it, and then the second is to slide the triangle to the right. The third is to change the position 90 degrees clockwise. These flips and turns are called transformations and have special names which are listed in the table. So a flip we call a reflection. A slide we call a translation, and then a turn we call a rotation. If we say flip, slide, turn, the technical names are reflection, translation, and rotation. So a reflection or a flip produces a mirror image. So I like to imagine it like we have a true reflection, we have a mirror, and that mirror could be vertical, it could be horizontal, it could be at a different angle, but we have some place that a mirror is. So if you ever stood in front of a mirror and you're, say, 5 feet away, as you walk closer, obviously that reflection is appearing to get closer. If you touch the mirror, it looks like the reflection is touching the same point. So just keep that in mind when we're doing a reflection for a shape. So if we have the vertices 4, 3, 4, 1, and 1, 1, we want to draw and its reflection. So copy these down so we don't have to So let's go over here. Let's draw our and so we draw our x and y coordinates. We had r was 4, 3, so over 1, 2, 3, 4, up 1, 2, 3. R S was 1, 2, 3, 4, 1, and T was 1, 1. And now we're reflecting it. So pay attention. Draw RST and its reflection in the x-axis. We have to pay attention. So again, this is x and y. So sometimes we reflect it about the y-axis, sometimes about the x-axis. We can even do it across some other line. So we're doing it across the x-axis. So okay, t is going to be reflected. T is going to be here. S is 1 away from here, so it's going to be 1 away from here. And R is 1, 2, 3, 4 away, so it's going to be 1, 2, 3, 4 away here. And then this little symbol right there, we just use that to indicate that it's the transformed, either the enlarged or the slide or the reflected shape, S prime, R prime, and T prime. And these points was now over 1, down 1, so 1, 1, negative 1. S prime is over 1, 2, 3, 4, down 1. And R is over 4, down 3. So our original R is 4, 3, S was 4, 1, and this was 1, 1. So it went from 1, 1 to 1, negative 1. So the X value didn't change, the Y value changed. It went from 1 to negative 1. 4, 3 became 4, negative 3. The X value didn't change, 3 became negative 3. 4, 1 for S, S prime is 4, negative 1, 4 didn't change, 1 became negative 1. So it reflected about the x-axis, so the x values did not change, and then the y values just flipped. They were all positive here, so they became the opposite down here. 1 became negative 1, 3, negative 3, 1, negative 1. So we draw out our original and then our reflected, and we go there. If we have a slide, we can slide left or right or up or down. So here's our original position, A, B, C, D. Right here, A, B, C, D. We just plot our 4 points, over 4, up 3, over 4, up 1, over 1, up 1, over 1, up 3. And then just connect the dots. There's our rectangle. There's our original image. And then we are translating it or sliding it 5 units left and 4 units down. So we go over 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, over 5, down 4, over 5, down 4, and left 5, down 4 for all of them. And since we're moving all the points the same, we're not sliding one point any more than the other. So we translate it 5 to the left and 4 down, and our new points are negative 1, negative 1. So we start at 4 for our x value, and now it's at negative 1. That's because we went 5 to the left, or we subtracted 5. So 4 minus 5 is negative 1. 4 minus 5 is negative 1. 1 minus 5 is negative 4, and then D was 1, minus 5 is negative 4. Now y values, well, what did we do? We went 4 units down, so that's minus 4 in terms of our y. So 3 minus 4 is negative 1. 1 minus 4 is negative 3. 1 minus 4 is negative 3, and then 3 minus 4 is negative 1. So that's what we did. So we can draw it, which really helps. We can see what's actually going on, and then we can look back and see based on our coordinates, okay, we went 5 to the left and 4 down. So minus 5 on our x values and minus 4 on our y values. Okay, now our rotation of a figure turns the figure about a specific point. Usually the ones that we'll see, 7th and 8th grade, are about the origin. And we usually go in increments of 90. So 90 degrees, 180, 270, or 360, which gets us back to where we started. But we can do others that aren't about the origin, or we can rotate it 72 degrees clockwise or 192 degrees counterclockwise. But the ones that we're going to work with that makes it not necessarily nice and easy, but we don't have to worry about it, is 4 turns clockwise, which gets us back to where we started. 4 turns counterclockwise, which would also get us back to where we started. So one way to view the effect of the rotation of a figure is to trace the figure on a piece of transparency film, then place the point of a pencil at the center of the rotation and turn the transparency film through the described rotation. But I don't expect you guys to do that on a test, so I'm going to give you the rules here in a second. I'll let you write them down on your reference sheet. So let's take a look at 3. We draw the coordinates for a triangle PQR. P is 3, 4, Q 3, 1, R is 1, 1. And then draw its image prime PQR after a counterclockwise. So again, counterclockwise means that we're going to move to the left for us. When you think about a clock and you're moving backwards, that's counterclockwise, about 90 degrees about the origin. And the coordinates of the vertices. So we draw PQR. That's our first step. PQR, just the points that we're given right there. Just plot your points, connect the dots. We've done this with area and perimeter and different things, contractions and dilations of shapes. Now we're just working with reflections, rotations, and translations. But it's the same thing. Let's first just plot our 3 points, connect the dots. We have a triangle. Good. That's good. Now we're doing a 90-degree rotation about the origin. And so there's the origin. We don't always have to rotate there, but the ones that we're going to see are always about the origin. So that makes one extra thing we don't have to worry about. We rotate, so 90 degrees, P to P prime comes here. R to R prime comes here, and then Q to Q prime comes here. And then our new points become P prime is negative 4, 3, negative 1, 3, and then negative 1, 1. And the rules for this, and I will just give them to you guys, and you can write this on your reference sheet or remind me when you get into class. I'll put them on the board again for you guys to be able to copy down. But if we have again, since quarter turn 90 degrees, half turn 180 degrees, 3/4 turn 270 degrees, full rotation is 360 degrees. Okay, how we can remember these? So 90 degrees clockwise, whatever our x and y value were, they flip, and then x doesn't necessarily become negative, because if it was negative here, it would become positive. So x changes the sign. So that's what that negative sign means. So x and y flip, and then we change the sign of whatever x was. So this is a 90 degrees clockwise rotation. So again, 90 degrees about the origin, 90 degrees, here's our new point. That's a 90 degrees. Oh, I pushed it the opposite way. Go clockwise. Clockwise. So again, you guys know the clock, so if we rotate clockwise, we're going this direction. Counterclockwise, we're going to the left. So clockwise, counterclockwise. So I mean, just mixed you up there. So this was our original point. We're rotating about the origin. So this is our pivot point, so to speak. We're rotating 90 degrees, and we're going to end up here. When we do that, we know this rule applies. X and Y becomes Y, negative X. Whatever X was. If it's positive, it's negative. If it's negative, it's positive. 180 degrees clockwise, X and Y become negative X, negative Y. This was the point I was starting at, and I did 180 degrees clockwise, or that's the same as 180 degrees counterclockwise. If we're halfway around the clock, right or left, I end up at the same place. 180 degrees. I do 180 degrees clockwise. Okay, if this was X is 2, Y is 3, well, that's going to become negative 2, negative 3. So we're just changing the signs of both. Or again, if it was both of these values were negative, then they're going to become positive. So this negative doesn't mean it's always negative. X, Y here doesn't mean it's always positive. It means we're changing the sign. And then 270 degrees clockwise. Starting at x and y, whether they're positive or negative, 270 degrees clockwise becomes flip the sign of y, and then the y value goes to x, and you change the sign, and the x value becomes the y value. And 360 degrees clockwise or counterclockwise gets us, if we started here at 360 degrees, we would end up right back there. So it's obviously just the exact same points. Now remember, so the 90 degrees 90 degrees clockwise rotation is the same as going 270 degrees counterclockwise. This is writing them all out again. We can just remember this for 180 degrees clockwise equals 180 degrees counterclockwise. And then if we do 270 degrees clockwise, that's the same as going 90 degrees counterclockwise. And if we go all the way around our clock or our coordinate plane, 360 degrees clockwise is the same as 360 degrees counterclockwise. Okay, so you can write this on your reference sheet, and this is one that sometimes if I don't draw it out and I just want to find I'm like, okay, what's going on with the points? This is something that I will reference as well. So you guys can copy those down just so you have them. If you don't want it, that's fine, but see a question on the test with shape in a coordinate plane, and you have to do a 170 degrees clockwise rotation. It would be nice to have this just to do a quick reference and make sure that you drew it correctly, or your coordinates are correct. Okay, and then the last one, we've worked with these, we have dilation. So if we have the original and we make it smaller, it's a reduction, or a contraction, it's getting smaller. If we have the original and we're making it larger, then it's a dilation. So all we do is we multiply our coordinates by whatever scale factor is. We're making it twice as big, we multiply them all by 2. In this, we're given these 3 points, and we're told to dilate about the origin with a scale factor of 3. So 1, 1 becomes 1 times 3 is 3, 1 times 3 is 3, so 3, 3. 2, 1 becomes 6, 3, 1, 2 becomes 3, 6. So all we do, here's our original, it's going about the origin, so we just multiply all of our coordinates by 3. So x prime becomes 3, 3, y prime becomes 6, 3, and then z prime becomes 3, 6. So we see that this one is obviously larger than this one. The dimensions are going to be 3 times bigger, and the area is actually going to be 9 times bigger. So make sure you pay attention to that if you get a question about area or something like that. Okay, we'll do these ones together. Have this written down. Again, remind me when you get to class, I can write on the board or screen or whatever we need to, just so you have it. It's something that I would recommend having just as a reference if we see some of these rotation problems on a test. All right, that's all we have for today. That is lesson 80. Good job.